Video over the cellular network. What does it look like today? What does it look like in the future?
We'll try and break this down. So we have a unique video codec that is the best video codec on the planet for live video. Alongside that, we have some unique algorithms that work hand in hand with the codec that monitor networks and help the codec do its thing. So they're constantly talking.
Essentially, we could put a camera utilizing your product in Antarctica and be here in the UK and have flawless, no issues, no interruptions.
Over satellite communication.
Just satellite. That's incredible. So when are you guys going to go to space?
Is there a reason why we couldn't?
Yeah. There's
No reason why we couldn't.
No,
Although I do like the idea, just going back to your last point about Antarctica, I do feel an application called Penguin Watch coming up. Yeah, or penguin counting.
God.
It's a really easy question. I think what we're talking about is what's at the very edge.
Hello, everyone, and welcome to the Edge Tech Podcast. I'm David Kosloski. Alongside of me today, I have the wonderful Clive Sawkins, who is the Chief Operating Officer at Digital Barriers, and Dale Hall, who is the Head of Product Engineering at Digital Barriers. Guys, thanks so much for being on the podcast today. I'm excited to talk to you because from an edge computing perspective, what we're really going to be diving into today is around video over the cellular network. What does it look like today? What does it look like in the future? So first, let's start out. Digital Barriers, what do you guys do, and what is it that you solve in the video space?
So the primary problem we solve is that there's not enough bandwidth and spectrum in the world to deliver video over these wireless networks, ultimately. So our primary job is to get live video from point A to point B, reliably, robustly, cost effectively, without any latency or quality issues, ultimately. So you touched on cellular networks today. They're not really designed for the upload of video, which is what live video requires. They're very much skewed towards offline content delivery. So your social media, your Netflix, Disney, Paramount, your pure consumer grade. I want to watch them with my phone instantly. I want to do a video call. That's very much driving how spectrum and bandwidth is divided amongst the network. What problem that has introduced is, LTE and 5G were supposed to solve the problem of infrastructure so that people didn't have to have, fixed connections or fiber being run on roads being ripped up. But because of the bandwidth and spectrum issue and congestion, live video for mission critical and safety applications, or even just automation in general, is very difficult to achieve with the right level of reliability and quality.
So how does it work?
We'll try and break this down. So ultimately, we're a software business, but we take a video feed, and we have a unique video codec that is, in my view, the best video codec on the planet for live video. It's unique in that it interprets change much better than anything else that's been designed or that's released today. And alongside that, we have some unique algorithms that work hand in hand with the codec that monitor network, and help the codec do its thing. So they're constantly talking. Now, that makes us unique because most video codecs are only driven by content and scene changes. We do both. We interpret change highly efficiently, but we also adapt to how the network is shaping ultimately. So key USP is our ability to adapt in these ever-changing, congested networks, which are, we have more and more connections and, connected to networks. But again, there's just not enough spectrum to cope with that, with the quality of service that people require, especially in live video applications.
And how does this determine that the change? Is it through AI or is it algorithms?
So it's not live AI as such, but a lot, 25 years of R&D went into the codec ultimately, and it was, early machine learning, which was a early predecessor to AI as we know it today. Ultimately, what we trained to do was to try and be to perceive perception like human eyes do, which sounds crazy, but that's how it was trained ultimately. And how that works today is we have something we call code books, which are almost like smart algorithms that live in our software next to the camera on one of your devices, and also in the cloud, and that constantly talk to each other to say, this has changed. How much bandwidth do I have? And that's how they work together.
And when we talk about use cases, like how often is it that these cameras or these solutions that you guys are providing are at the edge?
If you look at the footprint of the units that we're using, the CPU that's now available, the lower power consumption, the wideness of the heat that we're able to control in those units, the boundary or the edge has moved. It's moving to places where it was never possible to implement before. So if you look at things like border force protection, we are at the very edge. The edge used to be the side of a building or where you could get some power to. That's changed with the new compute. It's moving all the way to where the implementation is required. Whether that's right at the edge of a border, whether that's on a location in a very large factory that has no fiber and they don't want to dig anything up and you can't get a wireless signal to work. I think what it's enabling us to do is to redefine the business case because of the compute and the power that's available. And the fact that the codec is so powerful in being able to uplink to networks in incredibly high quality video that was never before achievable.
A question on that, if you don't mind. So when we talk, I've obviously seen your devices around, and I think there's an interesting question when you say border security. I think the immediate solution based off the political environment, obviously, is that we hear like walls are the simplest solution. But are you suggesting that the security surveillance system could essentially be an alternative that's more cost effective?
100%.
And what stops then governments from not choosing a solution like that?
I don't think there's anything that stops governments.
Not anymore.
Not anymore, no.
Okay.
But we have multiple customers that are implementing in these types of environment to see what it's looked like, see how reliable it is and what the quality is like.
Is it just video, or would like thermal or night vision play into something like that?
Yes, we don't mind what type of video it is, daylight, thermal, it's just a video feed for us ultimately. But we can also transmit generic IP data as well. We're also very good at things like telematics. So, in this world, PTZ cameras, for instance, so pan, tilt, and zoom cameras, if you've got any sort of latency, they're impossible to use. You can imagine you move a joystick, the camera moves 3 or 4 seconds later, that's useless. We're unbelievably good at that. We're very active because we got such low latency as well.
Is there ever mobile deployments? So let's say there's a festival, we want to throw some cameras.
That's one of our strongest use cases. I'd say the ability, in this industry they call that RDKs, so rapidly deployable kits that can just be popped up, connect to a network with a roaming SIM card, or again it is even more remote, satellite terminals, and they've got eyes on for live situational awareness video.
So one of our customers deployed at Glastonbury, one of the biggest concerts and outdoor festivals here in the UK. I'm sure it's streamed globally. We deployed there to keep the audience safe.
Well, no other technology could do it. That's it. That's it. You have lots of examples of really congested areas. Glastonbury's one example, but there's lots of festivals or events that we're used because you can imagine there's probably 1 or 2 cell towers servicing hundreds of thousands of people. How do you get video across that? So that's where we come in and get that done for the end user.
Yeah, I've noticed that sometimes at large events, like my cell phone doesn't necessarily work. So how does that fall in line with the cameras?
So we clearly need a connection, no matter what. So, but the big difference is we don't spike ultimately. So when you're on your phone, you pull in refresh most of the time. That's a bunch of things in the background trying to grab data. So, once we're on a network, I said we're very flat. We look like traditional VoIP, voice over IP, ultimately. So, a network usually treats us very favorably. So we avoid any quality of service detections. But whereas mobile phones, like some video, is very spiky, and that's what networks hate. They hate bursts because you burst their capacity, and that's when they'll not allow you on your network, or they'll throttle you back or throw you off it ultimately.
What if 5G, 3G, it all goes down? There's no cellular service anymore.
So we do have some. Again, we're agnostic to Clive's point. And look, take the 1170 for instance, the 1170, that's got almost like redundancy built into it. So if it's a super critical event, we will use the internal modem as a primary communications method. But then because you've got, LAN ports on the device, we have some customers who will plug in a satellite terminal to that, a Inmarsat, a Starlink, something that's satellite based. We don't care who it is. We're proven to work with that for the last 10 years. So we can have redundancy built into it, from our software point of view and from your hardware point of view.
There has to be benefits then, right? Between like why, if Starlink was an option, why switch to 4G? Cost.
So clearly, cost and coverage as well. So clearly with cellular, you have much better coverage than satellite, and clearly more bandwidth usually, and cost is usually less than a satellite connection, or significantly less than a satellite connection.
When you talk about live events, I guess the obvious is an emergency system, right? And I understand the use case, but is it able to identify instances before they happen? And an example would be if somebody has a weapon on them and they pull it out. Or how does that work?
There's two elements to identifying a shape, should we say. So certainly in the case of partners that we have worked with that take the stream from our product, they're looking for a couple of things: high quality image, high quality sound. So we've worked with people that can recognize a gunshot. That's not our system. That's the back end using an intelligent algorithm that says, I recognize this sound, I need to alert someone. Our enabler is the fact that we can pass that sound and that video in such high quality across the network that a back end system can identify it. That's what we do.
That's perfect.
All at low bit rate, low latency.
Yeah. So what are the limitations, I guess? And if you had to figure, where does it sounds like you've already solved this massive issue, but there has to be limitations where you're like, well, we did, but this is the next step. What does that look like?
Right now, the big change we made as a business is to make this capability purely software only. So today, we're partners, our main partner, SNUC, our software is approved to run on, a couple of your devices, ultimately, the 1170 being one of the flagship devices. Now, where we've got to is we've now released this product as software only, so that you can run it on pretty much any general compute device, ARM-based, Intel-based, AMD-based, NVIDIA. So we're now at a point where people don't have to buy extra hardware if they don't need to, or if they want to use different form factor or a different profile, we can now have confidence to say, well, we run on pretty much anything. Here's our partner SNUC. They have a great array of hardware that fits most purposes. That's a big step forward for us. It takes away friction in the sale. It stops having to have things like two-box solutions, because most people will have, say, an LT router already, or maybe existing customers of SNUC have bought lots of hardware. They'd like this capability. We don't have to turn around and say now, you need to buy another device that's dedicated just for EdgeViz, which is our product set. So that's the key thing for us, is taking away this appliance model, ultimately, where you don't have to have dedicated hardware. Will run as a guest alongside other software on pretty much any general compute devices on the market today.
I mean, obviously I get the removing the hardware piece, but there's no growth that is, well, we use it for primarily video today, but we see it being utilized in this space in the future, or there are limitations in more rural areas. Yeah,
absolutely. I think the demand for video is only growing. So you can see in everyday lives, there's video everywhere. We're in conversations with autonomous cars. Everything is, data is king. Ultimately, there's so many systems that need data now, and video is the richest form of data you can get. You've got a video stream, metadata alongside that with what's happening. People need, there's eyes on everything these days. The biggest problem they've got is, what do I do with that video? How do I get it? How do I make it valuable? How do I make it so that it is protecting people, or doing predictive analysis? So it's everything from cars. We have farming applications in rural areas. There's telemedicine. This video can solve so many problems, but fundamentally, you have to be able to move that video around efficiently and effectively.
we're stressing a lot on video, but what I have to ask then, we have these little drill bits over here. That's not video.
No, sure. So clearly, like, there's two modes to use video. There's ultimately you can stream constantly, which some people do, or there's event-based video. So, trying to drive efficiency, only moving that video or viewing it when something's happened. So there's multiple ways our software can be triggered ultimately. And it's through an array of third-party sensors or analytic software that we've built.
That turns on based on.
Exactly.
Got it, okay.
So those sensors there are unattended ground sensors, very much used in our military customer base, or for border protection. Those can be deployed from up to a year at a time without changing the battery.
So even though you specialize in this ability to be able to send footage, you're almost providing other solutions to problems as a part of this. Like almost while you have the interface or the transmission, you didn't need to do that.
No. Sure. That again, I think that just shows where we've come from, though. So this is our rich history. That's that's where we started ultimately.
But in many ways, we did need to do it. So if you think of the end user application, they want to monitor an area over an extended period of time. You suddenly then start to question, well, how much power do I need for that extended period of time? So if I can shut my unit down and quickly start it up when there's an event, you start to think slightly differently. So when you think of that, you go, so how am I going to trigger it? Is it going to be a ground sensor? Is it going to be another video triggering this off? Is it going to be noise? You start to look at your product as an element of the solution and then how you're going to trigger it from other places. That's why we did all that. So yeah, video is still core to the solution, but actually how you're turning it on based on an event at that point in time is quite unique.
And do you find that you're going to predominantly stay in this, we have to move over to SaaS, or do you think that there might be opportunities in the future for other solutions similar to the uniqueness that you guys have with the sensors?
So markets mature at different rates. I think we have various verticals that we support and their needs are different. So in some applications, we will stick with our dedicated hardware for a piece of time because it's so important in the end-to-end solution. In other areas, especially around SaaS, we have moved very, very quickly in the way that the market has moved. The way we enable AI at the back end has moved very, very quickly in some of the products that we have in the portfolio to be able to pass that information that they can use for analytics. So if there's one thing I've learned over the last few years is one solution does not fit all, but the core software, the core application does, and we can adapt it very quickly to multiple use cases.
But I suppose the key thing is it's now very flexible as well. It's not just it can run on any hardware, it can integrate with pretty much anything as well. So any camera or any third-party sensor or analytic, that's what's been key for us, because there's hundreds of sensors in the world that are not video, and there's thousands of AI applications that are on the market as well.
And if there's another thing that I've learned is, we're reasonably smart. We built a lovely piece of software that does an immense amount of work, but our customers think completely different to us. They think of applications and deployments that we've never thought of. And I never thought I would be having a conversation with a water company about managing effluent going into rivers using our technology. Never sat here and thought, let's drive a marketing program for the water board. You just don't think that way. But they did. They saw the use of our technology and went, that's fixing a real business problem for us.
I think, and just to clarify, as we kind of wrap this up, I'm going to use a really wild use case that may or may not exist. But so essentially, we could put a camera, and I know that you're not a camera company, but we could put a camera utilizing your product in Antarctica and be here in the UK and have flawless, no issues, no interruptions.
Over satellite communication.
Over satellite.
Yeah. We do that today. We got users who stream this from maritime vessels in the middle of the ocean with live video. Helping with health and safety, iceberg detection. That's done pretty much today using satellite communications and our software.
That's incredible. So when are you guys going to go to space?
Is
there a reason why we couldn't?
Yeah. There's
no reason why we couldn't.
No, we've had some conversation.
Although I do like the idea, just going back to your last point about Antarctica, I do feel an application called Penguin Watch coming up. Yeah, or penguin counting.
God,
Might be worthwhile.
we've done puffin counting.
Yeah.
So yeah.
So basically, the next time that I see you guys, hopefully you'll have something in space that is completely just no lag, no stutter. And we could say that's where you're going next.
That would be super cool. I like that challenge.
Yeah, that'd be great.
Well, I think that the aim is to move this from a specialist capability. We want this to, this is available to everyone to use ultimately with partnerships, with partners like yourself and with our partnerships with the mobile network operators, North America and Europe.
But if that's the case, so I use an example on one of our other videos in regards to a camera company that has a delay because it's on this network. Is the cost from a consumer perspective, is it possible that there is a solution? Like, what's stopping these companies from reaching out to digital barriers to say, hey, I want to be able to allow consumers to be able to get immediate access via
so very, very, very cheap consumer hardware. So we are a CPU based software. So, we need a little bit more
power, more juice.
But again, we are constantly trying to optimize that as well to make it as low footprint as possible.
But also remember, or just to seed a thought as we start to look to wrap up, if we're doing our job properly in the transmission of real-time video, no one knows we're there. So we are the secret sauce that sits in the network that just makes this happen.
Yeah, the man behind the curtain.
Exactly.
Yeah, that's cool. Guys, thank you so much for spending time with us today on the Edge Tech Podcast. Really appreciate it. It was very informative to see kind of how your solution integrates at the edge and allows for us to get flawless video, if you will, so uninterrupted. Thank you all for listening to the Edge Tech Podcast. Again, I'm David Kosloski with SNUC. See you soon.